And welcome guys to another little tower defense tutorial. Now today we are going to discuss and extend upon our little classes, if you will. Now in our tower defense we just got this basic tower, and I've just made it into a basic single point right now because the dual point. And I found a small tiny bug in the code for pointing at a direct target, and we'll be discussing that in a bit. But I've also extended into some other scripts. We've got our tower base code, now a base TD saveables, which will give us limits and other types of things that we'll need for the save system, so we can save like what tower, what position, things like that. And we got a TD limits. Now this class's job is just to keep account of how many turns we have in the game, and to just basically keep account. That's it. And we will be using that to set up limits for certain towers. Like if you had an extremely powerful turret, like I don't know, maybe some missile silo, but you don't want the player to be able to have more than one, then this system is for you. Okay, and that's its job. So if this was an extremely powerful turret that you can only get once, then you could set it up here, in our little tower limits thing. And you can make probably a nicey little how could we put this, little window thing, with a bunch of sliders. That way you can limit something per level. Yeah, you could do that. Or vice versa, but I just made it just a little simple array, and then that array gets plugged into the rest of the code. Now we should probably look at what changes to make to fix that little bug and things like that, which is very easy. And we'll swap over to some code now. So in our tower defense thing, I did the full range, and I put 3D. I changed the wording a little bit, so that way we know this is for a 3D game, or the method is 3D, not just 2D. Very more descriptive, and I've got changed the lerp to the appropriate one. Okay. Now the script right here for the TD abstract class, I put some comments, and you pretty much know what this is for lerping to a 3D point. Okay. The vector. Now the bug was actually, this used to say local Euler angles, and that would be wrong. You do not want local Euler angles, you want Euler angles. This is for the outside world, okay? Not a local space, but the entire space, like world space units, okay? If you do local units, it only does the local stuff, and it doesn't work correctly. It's off by a whole 90 degrees or so. So that's where that bug comes into play. Okay, and that's pretty much it for that. Okay. Now for the 2-point system, I didn't find any bugs or anything like that in it. I just changed the 3D and put some comments up here, blah blah blah. G is used for vector array, describing what these all mean, which is pretty simple. Let's embiggen this a little bit more. Okay, so we have my lovely squeaky chair. The lookup points, and that's great. And then we have this new function in here, target check, is for minusing our stuff. This is very common when you're doing distance checks and stuff like that to have this. And well, I'm okay with it and everything, but the problem is I keep writing this in every single tower. Okay, if I keep writing this multiple times, it's not going to make it more efficient or deficient. It's just a pain in the butt. Okay, so I made a function that does all the calculations I need. I pass a vector 3, which is what I'm checking anyway, my target transform, and my transform. Okay, and it does all this stuff for me. All I got to do is call the function, and that's it. Alright, same thing with here. This range check in tower defense games, well, the ones I've been making, we always are doing range checks. Range. And it's kind of annoying because the same code, I'll be writing this code right here multiple times. And I'm not going to lie, I get tired of saying vector 3 distance and this and this. So I made a function for it that's in the base tower script. That way every single script has access to this that ascends and descends from the tower base. So I don't have to do this ever again or write some of this stuff. All I have to do is write directly into this function and bam, pass 3 things in. That's it. And this keeps me from making a mistake. Okay, if I have problems with the range check, I know where it goes. Okay, so let's say I have 10 different towers. Okay, but one's messing up, so you know it's in the code in that tower, but do you actually know what it actually is? You know, I've wrote it several times in 10 different scripts. Each tower has probably its own script, but if it's a range problem in that single script, then I know where to go. But you know, it's the thing about it is I have to look for it. Okay, that's fine. But writing it that many times is kind of dumb. I mean, I'll still have to write this, but I may have this in combination with a bunch of other stuff, like this target thing. Imagine this being a function for target validation. I could put all these common things in here. See, this has got a target. This has got another vector 3 in here. Then it's got my tower. All I'd have to do to pass in something like this is make a float in here and start combining these into a validation function. Like this could be a huge function that does all that necessary code. I could basically put, hey, when the collision happens, or however you pick your target with, you know, we'll probably do collision or vice versa, but this bool could be used to validate our range. Validate, hey, is this a valid target? You know, you could do a target check, range check, and you know, that's basically what we got right now. Oh, and later on we'll be doing one for the angle of it. Is it within a certain angle? If so, then can we fire on the target? This right here could be a function for every one of those methods. So I can basically use one function call in my tower class to do all those checks for me, and it'll be so usable because hey, angle, cool, range, cool, target, Yep, he's an NPC. Bam, done. And the thing that I like about it is because it does all those three methods for us. If we have problems on a massive scale, like all of our turrets don't do something, then I know it's going to be in some of those method calls, like the target validation. I know that's no good. I, and if it all works, then I can move on. Because a lot of times you have these codes that you write multiple times, and sometimes it's great to combine all of them into a single call and a single method, because it's just like our raycast job. Okay, in our other project we have a raycast, we hit a player, and then we have a method for validating it, we have a method for what it actually is, and then we instantiate, bullet holes, do damage, or any of those other stuff. That raycast, we can make a custom raycast that does all that stuff for us in our weapon class. And the whole point of this type of functions here is to make an API that's programmable for our, when we start making the turrets into our final approach. Like, let's say we're releasing the game and stuff, we're going to have these tight-knit scripts that, are very more readable. If it's a range problem, we can go into here, that's fine. If it's a target check, like this, which I doubt it, but, if it's a angle thing, we have our angle, right? We have our nice little towers here, that do the lerp. And I hope you're starting to see the pattern in here, that we are just basically bypassing Unity's API and going into our own. The only time we touch Unity's thing is to do the game engine side. Okay? Our logic is pushed into custom functions that are designed for the turrets to be easier to develop. Like this upgrade class, we're going to pass the upgrade in our turret. Okay? And what we'll end up doing is deleting our turret, but before we do that, we're going to get its location, rotation, and all that good stuff. And then we're going to slam down the upgrade on the ground, or whatever. Okay? But before this, we're going to have us a nice little validation code. Is this allowed? Okay? Because we don't want, in this design, we're going to be able to limit what tower, how many, and things like that, which, that gives us the flexibility to basically keep the players not like super overpowered for certain levels, and creates a balance. One turret can't take 100 units out. It's just like firing rate and damage when you're doing first-person shooters. You're going to have some guns that are really great, but they got slow firing rate, and then you're going to have ones that have fast firing rate but have very little damage. So you actually have to have skill to be able to use that weapon efficiently. This is the TDBase class. Now, to get into this is a mono behavior that's abstract. So we will have to, basically inherit from this. Okay? Which is our savable class. Okay? Our savable class is abstract as well. We inherit from TDBase because the saving class, anything that we need saving, it's probably going to be at turns or vice versa. So we're probably going to have this in every single one of them. Now, this doesn't mean right here that when you go to your basic tower class that you have to inherit from this. You can inherit from TDBase still and make it where it will not be a savable object. Okay? It doesn't need a saving values or anything like that. So basically you're going to go, hey, no, you're not going to be saving. Do this instead. Which, is perfectly legit, I guess. It all depends on your game. So we have our savable class right here. I have enable. We go to TD limits to limits. And we pass this class right here. And we have a public name. Okay, it's just a public string, the name. And I have disabled and on destroy. Because as you remember, when we destroy something, disabled does not get called. But when we disable something, destroy does not get called. We need both because we need this to change the number in our limits class to the appropriate amount that we have. And that's one of the things that this class does. Now there isn't a saving method into some form of saving system yet, but this gives us our limits properties, which I found that this was an appropriate place for this at the current moment. Because of, even if we took this out and put this someplace else, we still need this because we need to limit our towers. Now, if this wasn't one of the features that you wanted in a tower defense game, all you'd have to do is delete these functions right here. And that would be perfectly legit, I guess. But I found that this could be useful. Now, we go into our TD limits class. This class is full of different types of statics and things. Now, we have an array of limit caps, okay? And what this is just a class with a name. I put TB, should be TD class, but oh well, we'll leave it that way. And then a number, which is an integer, a string and a number, that's it. And this will be serializable so we can see it in the inspector. If you don't put this, you can't see it in the inspector, and it makes it very hard to put those limits in the array that you want. So we have a static dictionary here of TD max, okay, which is for comparing and stuff. We pull it up through a dictionary. Yeah, you can iterate through it, but I was looking at it this way. If we wanted to do an iteration every single time we go to add something, that's going to be quite a bit of overhead. I mean, a loop's fast, but to do something every single time we've got our turn in the game being instantiated, because in our level load, we're going to have some type of saving and loading logic, right? And after it loads that, it's going to have to put all of the towers that's in our game back in. So if we have, like, let's say 20 towers, we're going to have 20 iterations. 20 iterations just to be able to plop down all the towers that we had from our saved game. We loaded into the world. So I was like, man, that would be pretty heavy. So we should probably just go ahead and put this in a dictionary, because it would probably be faster than the for loops at that point, because it's going to have 20 of them. Not saying that it wouldn't be, but when it comes down to it, I think we better stick with the plan. And two, we're going to be checking this a lot. You know, in our button, if we have a button, we're going to have an X mark happen when we hit the limit for that type of tower in the level. So every single time my mouse goes over the button, I may have to have a message pop up. Max of this type, blah. Maximum reached. Or an X mark there, where you can't have no more of them. You know, that's just the way it is, right? And then we have this one, which is going to be our current one. Now I had this private to this class because I didn't want to be able to access this besides in here. Okay? And this only happens in the start. What I could do is in the start, have this created and just type it into the class, like hard code it. But that's not going to be like something that you probably want. I mean, come on. It's going to be hard coded. And if I make a menu where you can change this as the player, you know, then the hard coding gets a pain in the butt. So here's our start method. In the start, we make sure that the dictionaries are instantiated. Yes, I could have put it up here and everything else, but sometimes they don't want to be serialized and in there, so it's just safer sometimes to do this. Okay, now we have our loop right here to add the data from here. That's all that does. This is a for loop. TD cap length blah tower limits dot add to the dictionary. This is the limits class right here, TD limits. Okay, and we put the key in. I'm actually instantiating this into the wrong thing. Actually, no, I did not finish this, actually. Well, that's dumb. Yeah, I totally messed that up. In the limits, we shouldn't have this right here, okay? This right here shouldn't be here, okay? What it actually should be because this is the limits, we don't want it in TD max. We want this to be 0. Okay, we want it to add 0 in here because that will be the current thing. The start of the game, it's going to be 0. Yeah, glad I caught that. Now the TD limits has to be added. So we're going to have to do another loop probably, which is fine. I don't know why I didn't put that. And it's going to be td.length. Yeah, that's going to be it. Okay. And it's going to be TD max dot add. What are we going to add? Our TD cap, and then the thing that we're going to be having, it's going to come from TD cap dot TD cap. Yeah, I know. It sounds really weird when it's like that. Kind of sucks for that, but you know, it is what it is. Which, in the interest of not looping to death and everything like that, we could put this in with the other loop because it exists and it's the same length and all that stuff. So we don't need this loop here. Nope. We can actually put it all in the same loop. And it'll be fine with that. You're just adding to the limits the initial thing, and then you're adding the caps in, which will have the same key in the instance. So that'll be great. That'll be just fine. So in our next thing, we're setting up two limits. We pass in the tower, the base tower savables class in here, just to we put it in here just so we can write all the code that it needs to do in here for the dictionary's lookup. Now this is just a dictionary check to make sure the dictionary exists. If it's null, then it gets instantiated. Okay, there's nothing in it and stuff, so it'll still throw an error. But I put it in there. I'm probably going to put something else in here just to we could, but the problem is going no we can. And this will keep it from airing out and stuff. This will probably be a good way of having this happen anyway. Because it'll let it continue. If it's being instantiated, we can go in here and go tower limits dot add. What are we going to add? A key, which will basically be this. And then we can put 1 here. And you're probably like, why are you putting 1 here when it's going to continue to the next line? Like here. You're right. It's going to continue to the next line. It's going to be all bad stuff. That's why I'm going to put a return. And you're probably thinking, well, why are you doing this? Well, this only runs when the dictionary is null, right? When the dictionary is null, it runs this code. So if this code doesn't run, this code will. And it still does the same job. We're just basically throwing the key from this class in by the name and putting 1. Not 0, but you'll have to have 1. Or to be off by 1. That would be kind of weird. Now I'll make sure that I save that. Okay. So that function's explained. I made this a public static. Okay. So when you go to call it, you'll be calling it like you would in the savable class. TD limits dot blip. And that's it. Okay. Makes it very flexible like that. Okay. Now we have remove from TD. Okay. Now, in this one, I'm not going to change anything. Because if, well, yes, I am. If the dictionary is null, and we're trying to remove something, I don't think we're ever going to have to change anything in here. If we're trying to remove something from limits and the dictionary doesn't exist, we've got an error of some kind. So what we're going to do is we're going to return early. We're going to throw debug dot log error in here. There is a problem because you're trying to remove from limits and it's a null dictionary. Ugh. Hate lines like that. And we're just going to bail out early so it never runs this code. Which, you know, that's just the way it is. It is public as static, and we pass in when we call itself the saving. Same thing. We're just subtracting. Very simple. Now, in this code, we have our lovely public static is our maximum TD max reached. We pass in the string and a bool, okay? And I'm pretty sure this will always exist because of this reason, but any tower that's running this code will have to push in a string and a bool into its overloadable method, you know, for calling it. And tdlimbs.contains key, if it doesn't contain this key, false, then we return true, always. Now the reason why we do this is if the key never exists, then we return false, is for errors, okay? If we haven't put that kind of key into the system, we want the system to run regardless, okay? Basically, if I don't put it in that little array, it'll always return true and we can just keep going. So this means any tower that I don't want to limit will always return true to be able to spawn into the world. We don't care how many they are. It just won't matter to us. It'll probably still exist in the dictionary because of our savable class. Actually, no. We pass this, but we don't actually add that key. Two limits. Yeah, we don't actually add that key. That's a crocky. Huh. Yeah, we'll always have to have the key to everything. Oh, well, I might have to change some stuff. Okay, that's fine. That's fine. Return true. Okay, that's great. I'm fine with that. That's easy to fix. So, all of our code will run here. Alright. So the key doesn't exist. That's fine. So we're going to put something in here. Okay. So we're going to have to add a key. because toLimits is going to subtract the toLimits dot name. Okay, and it's always going to add. We don't actually have to add to the limits itself. That's fine. Tower limits dot add, and all we need to do is add the key. And then we'll put a 0. Because our other script will take care of that call anyway. All we do is add it to the collection of keys. And the rest of the system will work. I'm glad that I freaking caught that. Or that would have been a big blow up there. Whew. So now, since it returns allowed, the whole rest of this code will not run. Okay? Once it hits this, it returns its full value. It doesn't run the rest of this stuff. Okay? So we've got it if it doesn't contain the key. Alright, so if it does contain the key the next time, TDBase. Okay. Crap. We are going to have to add it to that collection too. Well, that's just a crock. Well, that's okay. td.max add td key, and we'll put hard code 100 in there. 100, why not, right? More than we'll ever possibly have in the game, probably, or maybe not. You know, maybe that's the maximum for all objects. You never know. So, we took care of that. So, if tower limits dot key is less than or equal to the maximum in our key name, so we're comparing two dictionaries values to make sure they're not greater, it returns true. Is allowed equals true, and it returns. So this function just returns, never runs this stuff. But if we make it down to here, it returns false. So basically everything here will do the true statements. If we make it past here, like let's say this has reached its maximum and it's contained into the dictionary, so it contains key is true, it's greater than tower defense's max, TD max, then it will make it to here and return false. Which in our game, you know, if TD max has been reached, then it's not allowed. You can't do that. And we'll tell the spawning system, or because I'm pretty sure this is going to be for the spawning system, you know, because we're going to need a custom spawning, so that way we know, hey, how many we have, is it allowed, boom, there you go. You're going to have checks and stuff, right? And this is going to be used heavily probably in the game. Now, I'm not saying that, you know, you should do this, but because comparing dictionaries might be a little bit heavy operation, but think about it. We're only going to be doing it when we're trying to spawn towers into the game. And if you're a tower defense game, usually you're doing this with money, okay? So can you afford the money? And that's the next part. Because if your money isn't enough, you're going to be like kind of pinching along, like, hey, these guys that are coming, they're not real heavy and stuff, so we can possibly, you know, link that out with a cheaper tower, or maybe we have towers that are only good for airplanes, and then we have towers that are really good for tanks, but they suck for like your little army guys going across. The heavy machine guns might be the best thing for that, but they suck for tanks. And you'll have a combination just so you can kill everything and be awesome. So that's where we are with that. And we have this class done. We have the savable. But like I said, when we go to TDBase, and then we make a basic tower right here, this inheritance right here, you don't have to inherit from the save class, okay? If you do not want to inherit from the save class, you don't have to. All that save class does is do the limit stuff, okay? And it will also be responsible for pushing information into our some type of serialization class. Like, hey, for saving and loading, this class will be doing that. But if it's something that should be saved, like let's say, I don't know, maybe you don't want your bad guys to be saved into the saving class, which is fine. I mean, if they save and then load and then they're like, oh my god, I so messed this up, just have it revert back to its old save. But I'll point this out. If you don't save the bad guy's position, rotation, and stuff like that, and things, the problem with it is players could save and then restart their game, and every single time they load back up, they'll have no enemies, okay? So they could sit there and cheat by save, load, okay? Because in our saving system, we're going to be saving the tower, their health, and stuff like that. But in also other cases, we're going to be saving just players' money and things. So there's going to be some pretty complex different stuff to do in there. We're going to have some type of operation to do stuff. So that's going to be up next, but I think this video has gone long enough for melting like your brain cells and all that stuff. Because some of this I haven't discussed on this channel, some of it you may have. So let's try to pace it out and do it in a smaller step so people can understand it. So, here's Wardon, over and out. Like, hit, subscribe, and take her easy, guys. And I hope this helps you in developing a game. And thank you for your support and all that good stuff. Peace.